Hi, today I'll be solving and discussing 3 paper 1 questions from topic 8. And the first question asks us which statement must be correct given that solution HX has a pH of 1 and solution HY has a pH of 3. First of all, we will solve this by a process of elimination, and we want to reach the most correct answer or the best answer because the question asks us which statement must be correct without any assumptions made. A, HX is a stronger acid than HY. This might be deceiving at first, and this is the trick part of the question because normally we would say that HX is a stronger acid than HY given that its pH is lower than HY, but this is based on an assumption because the question did not give me the identity of HX for me to assume that it's a stronger acid than HY. The question did not tell me that HX is, for example, HCl or any other strong acid we must know, and the question did not also tell me that the solution HY is a weak acid. Did not tell me that it's ethanoic acid, for example, which we all know is a weak acid. Therefore, this is an assumption, and we cannot make this assumption, and so this is incorrect. For B, for the same reasons, we cannot make the assumption that HY is stronger or weaker than HX. And also, the details that the question has gave me are very limited. We do not know if these solutions have been diluted, and so we cannot make this assumption that HX or HY is stronger. And for this reason, B is also incorrect. For C, we know that 10 to the power of pH gives me, negative pH gives me the concentration of the hydrogen concentration. And so we can plug it in, 10 to the power of negative 1. This is the H plus of H plus concentration in HX, and 10 to the power of negative 3, 0.001. For HY, so these are the hydrogen concentrations for both solutions, and we can clearly see that the H plus concentration in HX is 100 is 10 times greater than that in HY, and also we can know that the pH as the pH increases, we know that the H plus concentration decreases by 10, and we can eliminate D based on this reason, because we know that as the pH increases, the H plus ion concentration decreases and not increases. And therefore, we can choose C as our answer. The second question asks us to find a molecule that can act as a Lewis acid but not a Brown-Sidlori acid. And here I would suggest first to look at the definitions of Lewis acids, and we know that Lewis acids are electron pair acceptors and Bl acids are proton donors before solving the question, because the definitions can be confusing if they're not solid. The second step is to draw the Lewis structure for each molecule. And here we are looking for a Lewis acid and not a Brown-Sidlori acid. So we need to check the checklist for each answer. For BF3, can it act as a Lewis acid? Yes, because it does not, because it is electron deficient. It can hold more electrons. So it can have 2 more electrons, an electron pair. And it is also not a Brown-Sidlori acid because it does not have a proton to donate. So this is the right answer, but we need to check other answers to make sure. PCl3, we can draw it as follows, and it has a lone pair, so it is a Lewis base because it has a lone pair to donate, and so this makes it incorrect. For NH3, for ammonia, we know that it is a Brown-Sidlori base. That's another thing, but first of all, is it a Lewis acid? No, it's a Lewis base because it has an electron pair to donate, so it's a Lewis base, so it's also eliminated. For H2O, we know that it is a Brown-Sidlori acid because it's amphoprotic, so it can act as a bronze lauric acid, so this eliminates it from the beginning, and it does not have it cannot hold any more electrons, so it is also not a Lewis acid or a bronze lauric acid, so it's also eliminated. This is the third question, and it is asking us if a student adds 0.3 grams of magnesium metal to equal volumes of HCl and ethanoic acid of the same concentrations in separate flasks, which statement is correct? First of all, we need to identify the strength of each acid. HCl, as we all know, is a strong acid, and CH3COH is a weak acid. And then we will solve through the process of elimination, like the first question. A, hydrochloric acid reacts more rapidly as it has higher pH than ethanoic acid. Hydrochloric acid indeed reacts more rapidly than ethanoic acid. However, it does not have a higher pH than ethanoic acid. It has a lower pH. And it reacts more rapidly because it has more H plus concentration, it has more flowing H plus concentration as it fully dissociates, so it reacts more rapidly, but it does have a lower pH because it's a stronger acid, so this is incorrect. And then a greater total volume of H2 gases produced with hydrochloric acid than with ethanoic acid. That is incorrect because they produce exactly the same amount of hydrogen, because this question states that they produce the same they use the same concentration, same volume for both reactions, and also the magnesium is of the same mass, and therefore the moles are balanced. So there is no reason that HCl would produce more gas, and this is probably deceiving for many people because for many people they associate hydrogen gas with reacting more rapidly, which is incorrect. So this is incorrect. And C, the same total volume of H2 gases produced with both hydrochloric acid and ethanoic acid. We just stated that that is correct because same concentration, same volume. And to understand this more, C times V, concentration times volume, is equals to moles. So if I have the same concentration and volume, I would have the same reacting moles in both reactions. So there is no reason that the H2 gas would differ in both of them. So this is correct, but we need to check if D is for D to eliminate D as well. Ethanoic acid reacts more slowly because it has a lower pH than hydrochloric acid. No, it reacts slowly. That is correct because it partially dissociates, meaning it has lower flow of hydrogen ions to react, but it does reach the same end product as I stated before. However, it has a higher pH, which makes this answer incorrect. Because it has a higher pH because it's a weaker acid than HCl. Therefore, our answer is C. Thank you.